Howdy, folks. Happy Tuesday. Hope you're doing all right. Alrighty. So we got a couple things today. Alright, so we've got the project that was due today to go over. Oh, goodness. Clicking all the wrong buttons. We're going to get into File I/O. Again, we're not going to do the whole chapter here, Chapter 15. We don't cover everything in files because we're only talking about text-based files. We skip all the binary type files in the chapter. And then just a little bit more about exceptions. Not too much more here. We did a little bit with handling exceptions from Chapter 5. So let's just touch on a couple things here in Chapter 16. So I'm not planning on a quiz on either of those. And we'll talk about Project 4 will be our last individual project here. And then next week we'll get started with Java FX. Again, it's maybe a little bit early here, but I want to make sure you get a whole 4 weeks to work on that final project if you'd like to take the time for that, because that final project is definitely the bulk of your score here. So that's the plan to work with that one there. I know we got things got pushed. Actually, no, I think that's right on schedule, right? Because we're kind of a weird schedule here with the way the midterm landed, I think. Yeah, we could have done the project here, but then we had the midterm. Yeah, so we'll do a little bit less for Project 4, not anything super crazy for this one here. Hopefully you can get that one done in just a week. And that way you can focus on the final project when we get there. So, because again, that one is worth most of your points here. Where did it go? Most of your points here. Here we go. 40% of everything is the final, and it's like all the projects combined are only 30%. And the lab's 10%. So hopefully those have been useful here. We have a lab too, don't we? We've got the Arrays and Arraylist Lab. We have the Project 3 to go through. I only got 8 submissions on the array. If you want to take a little more time on this lab, that's okay. Maybe we don't need to go over it today, if that's all right. Because definitely you should have a couple more people submitting that one, I think. But we'll go over Project 3 for sure. Yep, that sound good? So we'll start with that one. Hey, my Windows key worked. That's super cool. We fire up IntelliJ here. So we're going to build our plain class here. Right, so we're going to have a couple attributes. We're going to have get methods for everything. We're going to have a method or methods for enable and disable landing gear. Right, making sure we don't enable it if we're too high or disable it if we're too low. Excuse me, a change altitude, which will change by that value, positive or negative. And make sure we don't go above or below these 100-meter marks if the landing gear is on or off. Don't go below 0. Return Boolean true if everything was successful, nothing happened, or false if it didn't, like if we had to stop somewhere, the max altitude or 0 or at that 100-meter mark. And then unit tests to ensure 100% code coverage. And that we're just eyeballing, but we essentially want to make sure that every line of code in our class will run. So there's no main method required in here at all. It's just the class and the tests itself. So let's do a new project. There we go. And then if we did pick this Maven option, it sets things up a little bit easier for our tests. We can do it with Java, but we had to go and like add a new package and things like that. So I'm going to do the Maven option here. It should make life a little bit smoother for us. And I'll put this in the right folder here. I'm going to go in 1500 winter for Tuesday. And this was Project 3. In a folder called Project 3. Come on, Project 3. And everything else here should be fine. We'll get this one started here. Let's see. All right. Come on. Wake up. Okay, it's still not super fast either, but I think it's a little nicer than NetBeans is going to be. Okay, so we have the main folder, we have the test folder here, we've got our Java folder. So inside of here, we're going to put our package. So we're going to start a new package. And this will be, no, come on. It's got to wake up a second to recognize it's a package. That's fine. Add things. No, come on. It's still all loading down here, and I should just drink some more coffee. Actually, I'm drinking sparkling water now because I ran out of coffee. There it goes. Now it knows it's the Java folder and I can add a package. Now that it turned blue, it just took a little while here. We'll add a package. We'll call this project 3. Now we can add our Java class. And this will be for plain. Okay, so we're going to have our private attributes first. So we want attributes for make, model, number, max altitude meters, current altitude meters, and a Boolean for landing gear enabled. All right, so a couple of those here. Let me just grab all of those. We'll just, you can't just paste them in here real quick. All right, so private string for make. I should probably comment that out so it doesn't get confused. A private string for model. A private string for number. Like all of our planes start with NC, I feel like. I think that's a thing, like a Boeing 777 NC something, whatever. If you did it as an int, it doesn't matter here. That one's not important here. But max altitude, so that should be an integer. Max altitude in meters. A private int current altitude in meters. A private Boolean for landing gear enabled. Okay, and I think that gets all of those here. Okay, give it a little format. So now we have our attributes. Okay, we want get methods for all of the attributes. Now, if there's not a set method for something, we have to take it in the constructor, because there's no way to give it a value without doing that. So if there's not a set method for it, we need to accept that value in the constructor. Let's see, do we specify any defaults here? Yeah, so default current altitude to 0 and landing gear enabled to true. So we don't need to take values for current altitude. We're going to say when you make a new plane, we're going to assume it's on the ground. Right? Well, and I know altitude's not 0 everywhere. We're sort of cheating here. Just to make life easier, because it's kind of tricky to track actual altitude places. We'd have a whole lot of other code to deal with. Okay, so if I want get attributes, right, I code write them myself, but I don't want to. So I'm going to go to generate, and we want to generate getters. And again, there's no checkboxes. We control click all of them here, and we have getters. So now we can get the make, get the model, get the number, get the max altitude, get the current altitude, and is landing gear enabled, right? It's not a get for Booleans, it's is, because it's going to return a true or false. So it turns automatically to is landing gear enabled, which is pretty nice. So, the words itself pretty nice here. Then we want to make a constructor. So again, we could write it ourselves if we wanted to, or we could just let it generate some code here. So we want the constructor to accept make, model, number, max altitude. I don't want current altitude or landing gear. Right, so you tell me the make, you tell me the model, you tell me the number, you tell me the max altitude. We'll set those values, and then I'm going to say current altitude is 0, and landing gear enabled is true. So when you make a brand new plane, it's on the ground on wheels. Right? So that's our plane constructor. Again, you're welcome to do all these by hand. There's nothing wrong with that. I'd rather not do the typing. Okay? Now we need a method to enable or disable landing gear that has all this other logic here. So we're going to add a method. So public, and now this one didn't specify it's supposed to return anything or not. Just enable or disable. So let's make an enable landing gear method. I'm sorry, void, it doesn't return anything. And a public void disable landing gear. I like that they're nice and explicit. I think that makes life a little cleaner here. So to enable landing gear, we're going to say, hey, if my current altitude is less than or equal to 100, we'll say landing gear enabled is true. We'll enable it. If we're not at 100 or less, we're not going to do anything. Now for disabling, we're going to do the opposite. We're going to say, hey, if we are at 100 or more, then landing gear enabled is false. So if you're at 100 or more, yes, we can turn it off. Right, no problem. Now we should stop at 100, right? It should only work at 100, because we shouldn't be able to get below 100 without this being on, or above 100 without this being off. But that's okay. We don't need to get too complex here. Okay? Now change altitude. Hey, Y Paladin, thanks for following along, my friend. Hope you're in the mood for some Java classes and unit testing. Happy Blurs Day, my friend. Friends, if you're looking for a good time, just someone to hang out and good vibes and play some games with, you should check out Y Paladin. Also a quite skilled at technology sort of things. I forget what your actual role and title was, but works with a software company, I think, out on the West Coast. Definitely a good time. Definitely. Yeah. Go check it out. We can make lots of friends here on Twitch. All right, so enable and disable landing gear, and then we're going to have our change altitude. Now, change altitude was going to return a Boolean type. We're going to return it true or false whether or not this worked. So change altitude, and this was going to be an int for meters to change. Right, so we're going to accept an argument for the meters to change. Positive or negative is fine. Right, positive means we go up, negative means we go down. We're going to make sure we don't go above 100 if the landing gear is enabled. Don't go below 100 if it's disabled. Don't go above the max or below 0. And then if it worked, return true. If we had to stop at any one of those points, we're going to return false. So a couple different things to check here, right? Which gets a little bit tricky, but that's okay. Did I misspell altitude? Altitude. Saying I misspelled it, right? No. How did I spell it wrong? Altitude. Okay. I don't know what I had wrong before, but that's okay. Just type it again. So, if the change works, we're good. If it doesn't work, it's no good. So we kind of need to see if we're at 0 to 100, are we going to go over 100 where we'd have to stop? Or if we're 100 or more, are we going to go below 100 where we'd have to stop? So a couple different ways we could work it here. And nothing, we don't need to make it super crazy and try and do it all in one line here. We can do lots of different checks, right, to see what's happening here. But none of this is going to change the landing gear status. So the first thing we can do, we can say, hey, let's take our current altitude in meters and let's add to it the meters to change. Right? If it's positive, we go up. If it's negative, we go down. Now we can start doing some sanity checks, right? We can say, hey, if the max altitude in meters, if the current altitude in meters is greater than the max altitude in meters, we did a bad thing. We're going to say my current altitude. Well, we're going to pretend we just stopped at the max. You told me to go up 10,000 meters, and I can go only up to 5,000 meters. I'm just going to stop at 5,000 here, and I'm going to return false. This was no good here. Right, that was bad. Okay, no matter what, if we went above max, we're no good here. Right, can't do that. Actually, probably even before we check that, we should say, hey, if my current altitude in meters is greater than 100, and my landing gear is enabled, we have a problem. Right, I tried to go above 100, and my landing gear is enabled. So now with the Boolean, I don't need to say landing gear enabled equals true. That's redundant here. This already is true or false. So I can just say, hey, and landing gear enabled, because it's either true or false. And if it's true, then I had to stop at 100, right? So I'm going to say my current altitude stops at 100 and return false. You did a bad thing. You tried to go above 100 meters. You didn't turn off the landing gear. You can't go any higher. Right? This is going up. Either we stopped at 100 because our landing gear was on, or we had to stop at max. Right? And I think both of these actually kind of go with if my meters to change is greater than 0, right? Then I want to do both of these checks. That's that direction, right? If I'm going up, I need to check, did I go over 100 or did I go over max? Right, just kind of helping me like kind of group these things together so they make sense to me. So if I went up here, I need to make sure I didn't go above the 100 or go above max. If I went up and neither of those happened, I can return true. Life is good. Right, all my up cases were fine. So either the 100 I had to stop at or the max I had to stop at. All the other going up is okay. Right, if we didn't go above 100, that's perfectly fine. No issue here. So if we're going down then, we want to say, hey, if our current altitude in meters is less than 100 and our landing gear, you could either say is false, is one option, or it's more common you'd see not landing gear enabled. So, and our landing gear is not enabled, means we tried to go too low, we had to stop. So we'll set our current altitude to 100 and we'll return false. We did a bad thing. Right? We were trying to go down, we went negative, we went below 100, and we didn't have the landing gear enabled. So we'll stop at 100, return false. Otherwise, we can check, hey, if my current altitude is less than 0, then, well, that's not allowed, we have to stop at 0, return false. If all of those things were fine, we can return true. Right? We went down, we didn't go below 100 without landing gear, and we're fine here. Right, so we should be able to get to 100 meters and stop and have it be successful. So you notice we've got this block here, through 3 different cases to check here, and 1, 2, and 3 different cases to check here. So there's just thinking about how many different tests I'm going to need here. Common part can be extracted from if. What does it want to do? I don't want. Oh, okay. So they both ended with a return true. There we go, that's a cute change. So now I just have 2 falses to test, 2 falses to test, and 1 true to test. So they saved me a little bit of testing here, isn't that nice? Right? Before it was return true here or return true here. And IntelliJ saying, hey, by the way, you're returning true no matter what if you don't return false or return false. So we could put it outside the if else. Either way is fine here. You know, I kind of want it like this, actually, so I can test unsuccessful, unsuccessful, successful, unsuccessful, unsuccessful, successful. So I'm going to have 6 different tests for change altitude here. And that's okay. Right? We want to make sure that all these different blocks of code are going to run here when we try our change altitude. So that's the class itself. Right? Now we need to test the code to get 100% code coverage. So if we did the Maven thing, like this, we already have our test folder, it should just work. I can say go to test. If you're using NetBeans, it just works as well, which is really nice. Now, because we're using Maven as not Ant, JUnit 5 is fine. If you're over in NetBeans, you had to make sure we're using JUnit 4. A little funny with these different versions, I apologize. Don't worry too much about it here. And it says, well, what do you want to test? Well, I don't want to do any of the gets here, because I'm going to do all that with my constructor. I do want to test change altitude. I want to test disable landing gear and enable landing gear, for sure. Those are the ones I want to test. So it should give me some methods automatically generated here for enabling landing gear, disabling landing gear, and changing altitude. Now, all right, it's upset. What do we want to do? We want to add JUnit to the class path, or actually add the Maven dependency. Is that what we want? I think adding Maven dependency ought to work. Let's see if that works for us. We'll say add. Still figuring out all the cool things we can do here with IntelliJ. But that seems to work for us. I think is fun. Did that update the POM? It did. So what it does is it says, hey, add this dependency here and say, hey, I need this package here. That's all. That's probably the more proper way to go about it. But Maven does a lot of cool things for us behind the scenes. We don't need to care about most of the details. All right, so for our testing then, I'm going to add another test myself for the constructor. So just copy one of these here, paste it in for constructor. Constructor. Because we're going to test that constructor. So we're going to do our arrange, we're going to do our act, we're going to do our assert. Right, so what things do we need then? We know we're going to need to make a model, a number, max altitude, and then current and landing gear as well. We know those should all have some values here. So I'm going to go and pretty much copy these over. Now I have to get rid of the word private, and that's okay. I can do a quick little delete. Now notice a double click on a word will highlight the whole word for you. That's a little tip to make things easier. So make will be, I'm just going to say make because I don't really care what this is. Like you can come up with your own Boeing 777 if you wanted. Model, number, no, wrong button. Number, max altitude, we'll say like 1,000. Current altitude is going to be 0, and it's true. And these are all expected, so I should put all those in. Expected, make here, expected model, an expected number, just to make the names more follow the convention that we've been following. It's not a requirement at all. I just think it like makes life a little easier here. So these are all the things we expect to get back out. Right? So act, the code that we're testing here is the plane constructor. So plane equals a new plane, given the make, or the expected make, the model, the expected model, the number, and the max altitude. Right, we give it those 4 things here. Where's that cool little pop? It didn't pop up and tell me which parameter was which. That's a bummer. Thought I was going to do that. That's okay. And then we need to go and get the values back out. Right, so then I'll have a string for the actual make is my plane.getMake. Right, we're going to essentially test all of those gets at the same time here. I don't need a separate test method for each one because that's probably a little overboard here. Plane.getModel, a string for the actual number, plane.getNumber, a string, or I'm sorry, an int for the actual max altitude in meters is my plane.getMaxAltitude in meters, an int for the actual current altitude in meters, plane.getCurrentAltitude in meters, and then a Boolean for actual landing gear enabled is my plane.isLanding gear enabled. All right, so I got all the values. So I'm testing the plane constructor, then I'm going to get all the values out, and I can assert that they match. Now, this here's a little bit redundant. It's possible if you wanted to, you can put the gets right in your asserts. I've never been a big fan of that, but if you like saving a little bit of typing, then I can see why people are a big fan of that. We'll say assert equal, or assert equals the expected make and the actual make. There we go, the expected make and the actual make. Right, and we can say they match. And we're going to just go down the line here for all 6 of those. The actual model, the actual number, the max altitude, the current altitude, and the actual landing gear enabled. Now, this one here, actually, we could kind of cheat. You don't need to say, does true equal true? We could just say, assert true here if you wanted. The actual landing gear enabled. Right? I mean, setting it up is fine to say we expect it here, but we're never going to use it anywhere else, so, I don't know. Sometimes it's okay to take a quick little shortcut. And then we just pop all these in here and make sure they match. And I can run my test. So let's give it a run. Run our constructor test. Right, it's the same thing we would have done in the main method somewhere in another program, in another file. But now the computer's going to do that checking for us. We don't have to eyeball it. Because we knew, hey, if I give it these values and I print them out on the screen, I should be able to see what we did a system out print line for. But this way I don't actually have to print it out and look at it. Right, the computer's going to do that part for me. Because the computer's really smart. and it doesn't get bored easily, which is nice. Sometimes we get bored very easily as we're working on stuff, and just like writing an English paper, you miss that you actually type out something because you were expecting to see something. So our constructor passed. Look at that. We're pretty happy. Okay. Now, enable and disable landing gear. Now, a actual true pure unit test just tests one method at a time. We can't disable the landing gear until we've changed altitude. So I'm still going to call it a unit test because we're testing the one method, but the method depends on something else in the class. So just if someone wants to argue with you about unit testing, that's okay. We still want to test that our methods do what they're supposed to do, even if they depend on other methods. All right, so for the enable landing gear, we should just be able to call it, and it should work. Now, what we kind of want to test is that we can disable it, go back down, and then re-enable it. Maybe? So let's try it, because I feel like we want to make sure that... I don't know, maybe we don't care. So if we just set landing gear enabled to true. The problem is it already starts as true, so I don't really know if it's changing the value or if it just started as true, but that's okay. We won't worry too much about it here. So we're going to arrange, we're going to act, we're going to assert. So what we need here, we need a plane to work with here with new plane. So we're going to put that in the arrange section with make, model, number, max altitude of like 1,000. There we go. That's what I was looking for, these little helper titles here. That's awesome. Probably because I put variable names in there. I probably figured it out. Okay. And then what we're going to do is the code we're testing is plain.enable landing gear. And then we'll get the Boolean for, or I can show you if you just want to throw that in the assert here. If you want to save like one line of code, you can say assert true plain.is landing gear enabled. So some people like that format. They just put the gets essentially right in your asserts. So we could say, hey, the expected model is plain.get make. Nothing wrong with that. So it's a little bit harder to debug is all, but that's okay. Either method's perfectly fine. So we'll just assert that the plain landing gear is enabled. So the code we're testing, we assert it should be true when we're done. Right? For disable landing gear, before we can disable it, we need to take our plane. We need to change altitude. We need to go up 100 meters. Then I can disable landing gear, and we can assert false here, that the landing gear enabled is false. It should no longer be on if it worked. Okay, so let's run our tests. So I'm just going to scroll up here. We can run all the tests we want here. Let's give those a look. All right, it's thinking real hard about it. Just give it a minute. There we go. And so it shows change altitude is passing, even though it had nothing. So if it doesn't fail, it passes, which is a little bit funny, but that's okay. So they passed, though. Enable and disable landing gear worked. So by going up, we were able to disable it. Feel pretty good so far. Now change altitude. Now we need a couple different tests. So I'm going to set one up, and then we'll try and copy paste some. So I'm going to change the name of it here to say change altitude returns false above 100 without landing gear disabled. Sure. Hey, Bjark? No, we're just writing a class right now. I mean, we could use it for anything, right? The idea that this class is nice and portable is fantastic, and that's what we're going for. We want it to be independent of anywhere we want to use it here. Yeah, we could definitely use it in the web application later, because this plain class is so amazing. We can say we write autopilot software. Don't use this for autopilot software, please. All right, so our plain test then. So the first one returns false above 100, or I don't know what, going above 100 without landing gear disabled. It's big, long, and ugly, but that's okay. So we're going to assert. Oh, I'm sorry, arrange. My goodness, arrange. We're going to act, and we'll assert. So So what we need then, we need a plane. Plane equals a new plane. Given, we don't care about the make. We don't care about the model. We don't care about the number. We do care about the max altitude though, because max altitude is important. We can't go above that. So then I'm going to have an int for the expected altitude. It's 100 here. So now when I change my altitude, plane.change altitude, if I try and change it by 200 here, I expect to stop at 100 and to get back a false. So when a Boolean result here is what I get back from change altitude. And then I want in for actual current altitude. Altitude in meters. Look at that. I'm forgetting my in meters. And this is current altitude. Gotta name these things better. Is my plane dot get current altitude in meters. Right, give it a little format. And then we can assert. So we'll assert false, right, for that result. It should have told me no, that was not allowed. And then we can assert equals. There we go. My expected. I don't know why it keeps wanting to do that. And the actual. Those ones should match. Right, and we can give that one a run. And let's see, did it pass? It passed. Awesome. So we're going to do it again. I'm going to copy paste this one here. Now this time I want returns false going above max altitude. So this max altitude is now kind of important. So I want an int for max altitude in meters that I can set because I want to be able to reference this thing later here when I'm done. Right? So I'm going to give it the max altitude in meters. And my expected is actually going to be my max. Right? So if I wanted, I guess if I wanted to say my expected altitude should be the max altitude in meters. Then what we want to do is I want to take my plane and I want to change altitude to 100. Then I want to take my plane and I want to disable landing gear. Then I want to try one more time to change altitude. I'm going to try and change it, go up another up to max altitude. That should also be false, right? If I'm already at 100, I can't go 1,000 more. Right? But I had to get to 100 to turn off the landing gear so that I could keep going. Because we tested trying to go too high, right? With that, we weren't able to go above it here. And then is my actual what I expected, right? I expected it to stop at 1,000. Let's see if it stopped at 1,000. All right, awesome. So that worked. And then one last one here. Change altitude. Successful. Going up. I don't know. Sure. So I don't care about the max altitude, right? I'll just put it back to like 1,000 here. And expected altitude, we'll say, how about 50? And then what we want to test then is if I go up 50, it should be true here. I should be able to go up 50 meters, no problem at all. I don't care about the landing gear right now, and it should tell me true. Because I know in my code here, right, our change altitude, we had, okay, if it's positive, it could either be false because we went above 100 or false because we went above max. Otherwise, we get true, and it just changed our altitude. So I'm going to say, okay, can I go up 50? Excuse me. Let's see if that one passes. All right, awesome. Yep, change altitude, successful, going up. That one worked. Okay, now we need the going down. Excuse me, that bubble water, my goodness. Now we need the going down. So I could go below 100 without landing gear. I could go below 0, or it could just work. Right? So I'm going to make another test here. How about we start with successful going down here. So first we need to go up, right? So let's say we expect to stop at 50 is fine here. So let's go up 100. So plane.change altitude up 100. now I should be able to go down 50 here. So I want to go negative 50 meters, and it should stop at 50 meters, right? I should go up 100, go down 50, and be stopped at 50, and it should be true that it worked. Okay, and then we have got two that should be unsuccessful. So this is returns false, false going below 0. Okay, so if we never go up, we should just stop here at 0. If we try and go down 50, it should be false. We can assert false. And 0 should be where our plane still thinks it is. Right, so we can't go below 0. Good. Now let's give that one a run. And then the last one is going to be going below 100. Return false going below 100 without landing gear enabled. Okay, so I can take my plane, I can change altitude to 100, and then I can plane.disable landing gear. So if I turn off the landing gear and I try to go down 50, I should still be at 100, right? Because my code says, hey, if we're going down and we try to go less than 100 and the landing gear is not enabled, we stop at 100. Right, so if I'm at 100, disable the landing gear. I should be able to disable landing gear because we're at 100, right? Set it to false. Then change altitude from 100 to go negative, go down. What's our current altitude? Is it 100 like we expect? Because we stay at 100. And let's go run all the tests. That should be all of them here then. And I believe that'll get us to 100% code coverage, just kind of eyeballing it here, right? We did a disable landing gear, we did an enable landing gear, we did change altitude 6 different times, we did all the different gets. That's all the code we have. And we did our constructor, right? Let's see what we get. All right, they all passed. So if one of them failed here, right? So if one of these, if I copy pasted wrong and I said this is an assert true here, it's going to fail, right? Let's just run this one. You can see it'll give you the big red X. Right, so the computer is going to be eyeballing it for us, not us, making sure that we got what we expected for some given inputs. So if we know what the class is supposed to do, then we should be able to say, okay, if I put this in, I should get this back out. And we get expected true, actual false. Assert false. We'll put that back. Okay? Now there's no main, we didn't need a main for anything. We don't ever need to make a plane. This is just the class code that can be used in a console application, in a graphical user interface application, in a mobile application, in a web application. We've got all sorts of cool things we can do with Java, right, with a class. So the class should be independent of any one of those tools. It just accepts values as arguments and returns values, right, with gets. We got all sorts of options here. Let's see. Did it work finally? Give it another run. All right, awesome. The test passed. Here, so let me go up and open up GitHub here. Hey, thanks so much for following along, my friend. Are you a fan of Dota 2? So I'll commit these ones to GitHub here. Not really? Okay. Just the attitude? I gotcha. Right, let me open up the right repo here for Tuesday. And we'll commit this, project 3. And push. All right, awesome. All right, so then for new stuff, then we got to get into files and just a little bit about exceptions. Again, not too much here. Won't be too big of a deal. Yeah, exclamation mark class. If you want a little more info, I guess it's not really a whole lot more info. I should probably update my bot. Yeah, but this is an intro to programming class. All right, so we finished up project 3. We'll talk about file I/O, just basic text files coming up here from chapter 15. And A little bit about exceptions. I don't actually know how much of 16 we need to get into because we did some of them up here. Maybe just a quick refresher. And then we'll talk about Project 4 tonight. And that'll be it for tonight. Again, we'll try and go a little bit lighter on the project. Nothing super deep because hopefully you can get that done before next. It'll be due in 2 weeks because that's the deal, right? We always have 2 weeks for projects. So I want to make sure you don't feel too slammed. But if you do want to get it done in a week, you'll free yourself up to start working on the final project a little sooner, which should be good. So we've got tonight for topics and then lots of Java FX stuff. I don't know if I'm actually going to have a whole lot on the 12th here of more stuff. So we might just have more final project work time. We'll see how far we get on the 29th and the 5th. So maybe we'll talk for a little bit, maybe not. Maybe we'll just leave it for final project work time. I'll put out a little forum here in D2L if you folks want to pair up that way. That's perfectly fine. I'd encourage you to work in pairs. Usually I require it, but we're still kind of in the midst of a global pandemic and things are crazy, so it's okay if you don't want to. But the project's the same, right? Because if you work in pairs, you have the additional work of coordinating and collaborating and meeting together. You're not really getting any less work than just an individual doing the project because they don't have to do all that other stuff. So. But it's a lot of fun. Actually, programming as an individual without working with anyone else is really boring and dull and lonely. And it's really helpful to work with other people and get ideas from them because coding really is that creative process. It's not, yes, there is science to it, but it is very much an art and very much creative. So you can generally get a better product when you work with more people. All right, so instead of starting files and taking a break in 10 minutes, why don't we just break now? We'll come back in about 10 minutes or so, and they'll start with our file topic, okay? I'll put some music on. We'll come back in about 10 minutes, and we'll pick it up from there, friends. That puts us out to, what, 6:58 or so p.m.? All right, see you in 10. Hey folks, sorry it took a little bit longer than I thought. How's everybody doing? Alright, so we're going to move on to files and then talk about the next project. That sound like a good plan? So we start with a new project here. Wow, look at all these fun types here. That's too many different things. I don't really want to pick from any of those. Let's do a regular Java project for this one. I don't think we need any of that extra testing stuff. Do a little basic command line app. And we'll call this one files. Files for a package. All right, so a couple things when working with files. But we're finally now getting to the point where we can keep data on the computer between runs of the program, right? Everything we've done so far has been in memory. As the program's running, it's maintaining that information in memory. It hasn't saved it anywhere. So when you stop the program, all that information goes away. So what we want to do is we want to use a file then to store that information. Now there's two types of files. There are text-based files and there are binary files. Right? Text-based files, when you open up, you can see the text. With a binary type file, it just looks like garbage if you open up with a text editor, but if you open it with a program that knows how to read and write that particular file type, it looks great. So let's go find, we'll just go put something in here. Let's, goodness. I'll go to Documents and GitHub. And for our class, if I put like a new Word document in here, a new Microsoft Word document, new Word document. A Word document is a binary type file. It has a particular type and format here. So I can open it up, and the Microsoft Word program knows how to go and read that data out and turn it into something useful in the application. Right? I can say, this is a test. We'll save and close it. If I were to try and open it up in as a text file, like with Notepad here, it's going to look like garbage because it's not text. Right? None of this is the text that we saved. It means something to Word. There's like information. Some of it is text here. Some of the information is saved as text, but most of it is not. So we're not going to deal with any of the binary files at all. We're just going to pretend like those don't exist here. Okay? We're just going to deal with text-based files. And to do that, we do three things. Right? You always do three things with our files. You open them, you read or write them, and then you close them. Okay? Those are the three things we do. So we want to start with, let's go write a file out here. Go grab, make sure to do the right thing here. So we're kind of not exactly following along, but going pretty close here with the book. So to write a file, there's a bunch of things that have to happen here, which are kind of funny. But we're going to use this print writer class. So it's print writer is the class here. We're going to call this our file output. Okay, and we're going to say it equals a new print writer. And what we give the new print writer is a new buffered writer. What we give the buffered writer is a new file writer, given the name of a file. So we'll say test.txt. All of that is nonsense. Don't worry about it. But the print writer uses the buffered writer. The reason why we like buffered writer is that it helps make sure that it is written out the disk properly. You can technically do without it, but it's nice to have. And then we use the file writer to actually make the file here. Now all of these need an import. Right? We want the java.io.printWriter, java.io.bufferedWriter, and java.io.FileWriter. Right? Those all come from the Java IO library. And now it's saying an unhandled exception. A bad thing could happen. We need to try and catch that exception, or tell Java we want to crash. And we never want to crash here. So we're going to put this in a try block. We're going to try all of this here, and then we're going to catch the IO exception. We'll call EX, and if that happens, we'll just print out the exception. Again, that's okay. We don't need to worry too much about it. Okay? So we've opened the file here. This is opening it. Now that it's open, now we can use that file output and I can write to it. So I want to take my file output, and now I have some commands. I have print or I have print line. Right? Print and print line are pretty familiar looking, right? Just like system.out.println, this is file output.println, and we can print something to the text, or to that file. We'll say test, 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 test. When we're done now, right, we've opened it, we've written to it, now we want to close it. We're going to call my file output.close. So we always do those three things. So we're going to, this opens the file, and now PrintWriter, if the file doesn't exist, will create it for us, which is really handy. Write to the file, and we'll close the file. Okay, so let's give it a shot. Let's see if this runs for us. Excuse me. I think it needs more fluids. Got a little bit more here. No, after drinking out of my super large mug, this can feels super small. Whoa. What did I do? Files.main. All right, let me try this build real quick. I think I got confused. That's super weird. Run. Why is it not? It's not finding our class here. Huh. Can we just hit run here? I think I broke it. Nope. What do we do? That's really weird. Let's rebuild, maybe. I'm gonna cross my fingers. So that should have worked, right? Finish the rebuild. No problems, right? That's fine, right? Nothing to do. Run. Let's try running it again. Wow. How do we break it? Hey, Light Jack, how you doing today? I don't know what we did to break it, friends. Huh. Let's see, it should generate a bunch of things when it builds. Let's see if that's what it's doing. Let's go take a peek. I think we confused it. $100. This is files. Oh, great. Yeah, C# a lot of fun. I like C#. Yeah, it's only... It didn't actually generate anything for us when it did the build. It's interesting. I don't know what we did wrong. Here's our working directories, files. Files.main is the name of the package. Right? SDK. That should be fine. I don't know why we broke it. Can't find it. So it's not actually compiling it here. Nothing got compiled. Recompile? Would it recompile? Source? No, nothing. There's nothing. My friend, I swear this just worked for us. Like with our last project, it was just good. We went and broke it. Yeah, I mean, we could. I just don't want to. Compile it from the command line there. God, my tool should just work. Let's just call it files. Add. I misspelled files. That's funny. That's okay. Let's rename it here. Refactor, rename. Spell it better. Files. And we'll take everything from there, paste it into files. Look at that, it added the imports for us. Let's see if we can delete main. I don't know. If it doesn't work, we'll do something else. We have files, so can we edit our configuration? So we don't want files, we want files class here. See if that works any better for us. Can't find files. It's not building. IntelliJ, you were supposed to be better than NetBeans, my friend. All right. One more try here. Let's forget the regular Java project. Maven was fine before. We'll give that one a shot here. Files, try 2. Give it a shot. Oh, and I closed out files. All right, we can go and grab it here. We can cut. No, oh man, I didn't even want that. It's not what I wanted. Sure, we can open it with Visual Studio Code. Code's fine. See if we can't get this added in here. We'll add a new package, files. If that's a bad name here, is that my problem? New Java class, files, install it in. Okay, let's give this one a shot here. We're going to try it. Run files. Yeah, we didn't even need to open this one. That's right. Close that down. See if this one builds something. It's building. All right, now I get this whole target thing, so I feel like it's building much better. There we go. All right, and now I see a file. That version was working before for us, so I'll have to see why it was complaining. But now we see our file is test, test, test. So we successfully wrote to a file. Awesome. Now if we want to read from a file, right, it's a similar process. We give it a couple things here. Now, one thing that can happen when you go to read from a file is it might not exist. So we want to be a little bit careful here. So one of the things we can do is you can make a file object. File equals a new file, and we can say it's test.txt. And you know, add our import for file. And you can say, hey, if the file dot exists, then we can go do something here, which is nice, because otherwise it might just crash on us. So if the file exists, then what we can do is we will make a buffered reader. We'll call this our input file equals a new buffered reader. And you give buffer reader, you guessed it, a new file reader, given the file object. So we give it the file here. So we make the file to give to file reader, which we give to buffered reader. Now this is telling us here that we have an unhandled exception. We have to do this. So again, we want to do this in a try block here. So it can be inside of here, try, and nope, this one. And then we're going to catch the IO exception, and if we catch it, we'll just print it out. Print out the exception. Nope, oh, that was not a curly brace. I have too many curly braces here now. There we go. File reader, where? Is that where the semicolon goes? Okay, a buffer reader given the file reader given the file object. Now, it should work because we know it exists, but we might not have access to it. So there are other things we can do. So this is opening the file, right? Now that's in the try block here. We're going to open the file. Then we are going to read the file. Oops, read the file. Then we're going to close the file. So when we're done, we're going to say my input file dot close. Close it when we're done. So to read it here, what we do is we actually go and ask it to read a line here. So we'll say my string for the line is my input file dot read line. And we can say while the line does not equal null here, right? We're going to print out the line, and then we'll say line equals input file dot read line. Right? As long as we keep reading something here, we're good to go. So it's possible if we just try and keep reading when there's nothing left. If you keep calling read line, eventually it'll crash on you and get an exception. We want to try and avoid that. So we'll read the line. If it's not null, we know we can print it because there's something there. If the file was empty, we get null back here when you try and read the line. And this should read every line out. So let's do a couple more lines here. So we'll do test, test, test. We'll do 1, 2, 3. Hey, thanks so much for following along, my friend. Glad to have you here. So that'll give us at least 2 lines here. Let's see what we get. Happy Tuesday, my friend. Just thinking about it. Here we go. We see test, test, test. We see 1, 2, 3. Looking good so far. Notice there's this empty line here, right? We went down a line with our last print. But we didn't have test, test, test from before. So you have to be careful. When you open this file with Print Writer, it is going to erase anything that exists there. So it'll erase any existing content. I love how this spell checks me, because I'm a terrible speller. So the Print Writer by default is going to overwrite anything, start from scratch, and then rewrite to it. So we can read files, we can write files. Now this all by itself is not the most interesting thing happening here. Right? This was just a quick little example. Excuse me. But what if we wanted to say, like, let's keep a grade book here, so I can keep a list of students and their grades, which I'm behind on grading things. I apologize. It has been a struggle to get caught back up, and things are still insane over in Europe and affecting my extended family. So I'm kind of a mess. I apologize for that. But I'm working on getting caught back up, and we'll get there. So if it's stressing you out, shoot me a message. I'll pull you up to the top of the queue. Hopefully you have a good feel for how you did on the projects, because we have the rubric you could score yourself on or do that self-assessment on. So I'm going to try to get the midterms done first, because people always stress about tests. And then I'll circle back for the projects. So there's our test file. All right, so if we put a breakpoint in here, let's put a breakpoint in here, and I'm going to run this in debug mode. We'll just go add some content to that file real quick. And now notice I just gave it test.txt, which is a relative path. I didn't say like c:\users\Eric or anything. So it's looking for the file in the location which it was ran, which is my files to try project here. All right, so we pause. So now I can go open my test.txt file. We can go add a bunch of other stuff here, right, as much as we want to add. Let's add some more gibberish here. Sure, perfectly fine. Now let's keep on going. So I'm going to continue running, and then when it prints out here in my console, we get all of that gibberish. Right? It's just going to, every line it finds, right, it's going to print out here. We just are looping. So just printing stuff out to screen is not all that interesting. What we want to do is we want to work with something with our files. Right? We want to be able to actually save some data that we can come back to later, like that gradebook example. So let's do that. Let's do I'm going to put all of this in another method here. I'm just going to grab all this and cut it out, and we'll call this static void file example. So it's all there. We can call that method if we want to, but this will leave main here to be kind of nice. Okay. So let's ask for then a bunch of students here, right? And we have covered arrays here. So why don't we make an array list then of students that I can add to? I don't need to know how many. We'll just keep adding here. So I'm going to make an array list of type string here for names equals a new array list. And yeah, we want to add that import, please. Oh, all right. Thanks so much, Mzudius. Good luck. So then we'll say, okay, how about we ask them for the name? Right. So we can say enter student name or done to be all done here. And then we'll loop, right? So then we'll get name, string for name. Oh, we don't have the scanner object set up. We'll set up our scanner objects. We'll say scanner. We'll call ours keyboard again, equals a new scanner, given system.in. Thanks so much for following along, my friend. We'll add our import. There we go. So keyboard.nextLine. And while name does not equals ignoring case, right, we want not equals ignoring case, done. We can keep on going. So if it's not done, we'll add it to the array list. We'll take names.append. Names.append. Names.add the name. And then we'll repeat here. We'll ask them to enter the name and restore it here. But now I don't need to tell it's a string again. We'll say, okay, enter the student name or done to be all done. Excuse me. And I know I have this here twice and I feel a little bad about it, but that way I don't need to check to see if it's not done before adding. Both ways are pretty much the same. Like if I asked them first, then I would have to check if it's not done before I go and add it, is all. I guess both ways would be fine, but either's okay. Yeah, Java in 2022. Believe it or not, it's still pretty popular. We could do some generic type, with T's. We don't get into that in this class. In the data structures class, we get more into that with generics. But we're going to give it a specific type here when we create this array list. So the array list is what you give it the type of. Yep, so we'll add a bunch of names. And then when we're done, then I want to go loop through and I want to go add all those names. So let's say, okay, enter the name of the class to save the list to. And then we'll get a string for the class name. Is my keyboard.nextLine. Now I want to create that file, right? So we do a print writer with a buffer writer with a file writer given that file name. So we're going to do it in a try block. I can pretty much close this or copy paste this whole try block here. And the name of the file here then will be the class name plus .txt. Oh, you still need the type here on the right-hand side. Yeah, I don't think we've gotten that fancy yet with the syntax. So we just do empty braces. You only give it the type one time. You get empty braces. Right, so then we will open the file, right? Given the class name, add the txt to it. And then what we want to write to the file is we want to write for every name. So we'll say for string name in names. Let's take our output file output, and we're going to write the name. Oh, we already have something called name, don't we? Shoot. That's probably fine. I think that'll be okay. That's just a warning, right? Yeah. We'll write it here, and then we'll close the file. So we should be able to get a bunch of names here then, and add it to the file. Let's give it a shot. Oh, is that actually an error? Goodness. Oh, it is. Okay, that's fine. Ugh. Alright, that's ugly. So string. I don't want to do n. N is fine, I guess. Right, n? That's ugly. It's probably okay. Maybe you'll forgive me. I feel bad about it. Let's give it a run. Okay, enter a student name. So Eric, Jeb, Vivi, Journey, Jubilee, Jackson, and Joy, and done. And the name of the class, this is family. And we should have a family.txt file. Uh-oh. I did print, I did write, I want print line. Sorry, print line, there. So it smushed them all together, that was no good here. Right, it didn't put any new lines between them. So let's do that one more time with the right print line here, so we get the new lines in between, be a little nicer. Okay, so Eric and Joy, Jeb, Vivi, Journey, and Jubilee, and Jackson. And then done. Right, now we should have a family.txt file. Oops, sorry, family. I forgot to give the name. There we go. Now it should update the file, and we get one per line. It's looking much better here, right? One per line. So now I save something, so now if I want to go read to it here, so maybe we ask them at the beginning, right? So we would say, do you want to update, create a file, or read a file? Right, and then we'll get their string for choice, keyboard.next line, and I mean, this is a little bit funny here, so we didn't really tell them what to type in. How about 1, 2, read a file? I don't know. Is that like, you think they're going to know to type in a 1 or type in a 2? We could do some better prompts, but this is probably okay here. We can say if my choice.equals, ignoring case is a 1, and so probably don't even need to ignore the case here because that's like number 1, but that's okay. We will go and create the file. Now this one, we might actually want to ask them, because this is create or update here, we could say, hey, what's the name of the file first? Right? And then go see if that file exists. Right? And then we'll have a file equals a new file given the class name plus .txt. Because most people don't add the extensions on. Most people just give it the name when they do that. And we can say, hey, if the, file, sure. File.exists, then we can do something. Or how about if it does not exist, we'll do this here and write it all. If it does exist, then we should do something else then, right? We should go load it first and then ask if they want to add some names maybe. So if it doesn't exist here, if it does exist, then we'll say, let's go read the file first. Right, so we still need to have this array list of names here. We'll go take that array list of names and we're going to go read the file. So we use the reading section here. Right, we use a buffered input file, a buffered reader given a file inside of a try block, essentially. There we go. Did I get all the try block? I think I did. And while there's a line, instead of just printing it here, we're going to take names, and we're going to add the line. And we'll read the next line, read the next line, read the next line. We probably also want to do one more check here too, and say, hey, if line dot is empty, and so if it's not empty here, I think that'll help skip that last funny new line here, because this last line is technically a line here, and it'll be empty when we read it. That's probably not what we want. Okay, so we'll go read all of the names here. So try catch, and then we could print out all the names, right, currently in the file. Names currently in the file. And then for string n in names, it's out n, right? And then we could ask him, do you want to add any or something? Do you want to add any? Yes or no? I mean, this is if we wanted to update the file. I mean, gets a little bit funny, but that's okay. And then a string for add is keyboard.nextLine. And if add equals ignoring case of y, this gets a little long here, but that's okay. So if they want to add some, then we'll ask, okay, what name do you want to add? Enter the name to add, or done to be all done. Right, and then we'll have a string for name. This is the keyboard.nextLine. Really, we can just copy this from here, right? What we were doing up above. We'll just keep on going here. Then when that's all done, then we need to go write the file again. Oh, well, okay, we can go do that. So this thing here, right, try and catch. Now, I think you're probably getting the idea here that we have the same code more than once, so we should feel bad about ourselves, right? Yeah, we should. So what can we do, right? Well, we want to take this that writes that to the file here, right? We want to turn that into a method. So we've got an option here. I think I can do this refactor extract method. Let's see if it does it here. Here we go. So this is write file. I like it. So write file, replace all. We'll take a class name and the name's array list here, and we'll try and write it to the class name.txt and go and write it here. So we can write the file here once we've done this loop here. Right, and this really we could even do as well as another method, right? Because we're doing the exact same thing more than once. So we just need to pass it the array list to add to here. So I'm going to take this refactor extract method. Let's call this add names to list. Sure. Okay, so we've got our scanner object and the names array, and then we can go do that. Awesome. And this one here goes and adds, and then reads the file. It's a little bit different here then. That's okay. And currently the file. Do you want to add any? Great. Oh, we didn't do our loop here. So we need to do that same method here then, right? Our same add names to list here. Do that same thing here. Add names to the list, and then write the file. Okay, so it's just doing the same operation for us. Right, enter the student name, get the name. If it's not done, keep on going. Add it here. Go, 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 go. And because we give them the array list as an argument, they can go and add to the array list. So that's the other fun thing with array lists. If you pass it as an argument, they can go modify it. Now, I can't reassign it to a new array list, right? I think we looked at that last week. I can't point it somewhere else, but I can go add and subtract from it, which works out pretty nice. And then for writing the file again, great. So what else do we need to do here then? So that we haven't done the read file yet. If we just want to read the file, right, that is this opens the file, really it adds it to names here then. So let's do that. So let's take all of this here, then let's pull that out. And let's extract that as a method. This is read file into list, given the list here. So then if their choice was 2, at the end of this if here, their choice was 2, else if choice.equals, ignoring case is 2. Again, the case here is a little silly, just my habit, sorry. I almost always do that. We will, oh, we don't know what the file is, right? We have to ask them what file to read. So enter the name of the file. name of the class to save the list to. That's fine. That's fine. We'll make the file. The class to read. We'll get their name, set up the file, and then when it's done, we're just going to print them out. So we'll say for string name and names, print out name. That was it. Okay, so you should be able to read, we should be able to update, and we should be able to delete. Or I'm sorry, read, create, and update. So if I give it family, I should be able to go add to it here. Right, so let's say family. Oh, look, I already have all these names in the list. Let's add some more. Yeah, let's add baby number 7. And then done. Okay, and then let's see if it updated the family file. It did. It added baby number 7. Okay, so that updated the file. Let's see if we can make a new file here. And then we'll see if we can just read a file. So, I mean, it should be able to read because we were doing that already, but let's see. Let's read a file, family. All right, that one worked. Sorry, now we'll do the create a new file. Yeah, that's fine. Excuse me. So we'll create a new one here. Let's say this is, I don't know what I'm going to call Twitch. And we had, what, Dota 2 show up, and we had Mizzou Diaz show up, and we had Lightjack show up, and then done. Right, and we should have now a twitch.txt file with a bunch of usernames. Look at that. We can make files, we can read files, we can write files. Some fun things with them here, with the contents. Now, still, this is just a bunch of names, not a whole lot of, like, it's not really a grade book yet, because all I have is names here. So if I wanted to store additional information, right, we need a way to store more things than just the name, right? So I can either write them all on one line per chunk of information, or I can have like multiple lines that will represent one chunk of information. Right. Different ways of going about it here. I like the single line approach, but that's just me here. So what we can do is let's go make a class for it here. So let's make a new class. We'll call this a student here. We'll say student has a private string for name, and how about a private int for score? And that's it. And then we'll make this easy. We'll add some getters and setters for these if we want. We can get name and we can get score. And then we'll add a constructor to make it easy as well. So let's generate a constructor that takes a name and a score. Okay. Then what we need is a way to get them out as a nice like single string here. So let's do this. Let's say I want to have a method for public string, I don't know, get string for file output. I don't know, that's a little bit ugly, but that's okay. So what let's do is let's return the name plus, how about this funny pipe character? That's the shift backslash, that's a fun character, plus score. So I can go get name and score smushed together here with a pipe character, because no one uses pipes for anything else. This is fun. We actually use this in HL7 which for healthcare data transmission. It's a pipe delimited format, which is really funny, this HL7 thing. Okay, so we'll get that. And then, excuse me, how about we, that should be fine for now. Okay. CC this pass un pipe. I have to go translate that. Something about not, this is not a pipe. Okay. Gotcha. All right, so instead of just the name of the student here then, right, we also need to get their score, and we can add that information as well. Oh, it's a painting? That's cool. So we're going to get add names to list here, but we don't want just a list of strings now, right? Because we want more information than that. So what we can do is I can have a list of student here. And we'll call this students. And let's change this a couple places here. It'll be okay. You just have to change a couple places. This will be an array list of students, right? And okay, now our methods here now need to be an array list of student here, so we can use our class in the array list here. Let's see, an array list of student, enter the student name, and then enter the score. So we also need a score. So let's get a enter their score and get an int for score equals integer.parseInt of the keyboard.nextLine. Okay, and as long as they didn't enter done, we're going to add a new student given the name and the score. Right, enter student name and the score as well. We need the score again. Okay, and we just keep on looping here, right? Adding the name and score, adding the name and score, adding the name and score for adding names to the list here. And then writing here is a list of type student. Call this students. Again, probably names is probably wrong to call that here. So let's right-click this and refactor rename. Call that students. Okay, same here. So we got students and students. This is a student, lowercase student here in the students collection. We want to print. Now we want the student.get name plus a pipe. I'm sorry, dot get string, right, for file output. We already have that here. Did I miss a parenthesis? Oh, yeah, somewhere up here. I got real upset. Student here. There we go. And then we should refactor this one and call this students too. Students, there we go. Yeah, students. And then again for student, currently in the students list here, let's print out student.getName, I guess. Sure, name's currently in the file. And do you want to add any? Sure, we can add names to the list, which is, we should refactor this one too. That's really adding students. Add students to list. Okay. And then this is my students collection again here. And for student, in the students collection, we'll go do that, right? Let's see, this is our array list here of type student. So a bunch of changes here, but not too bad. Not too bad. Students. Print student.getName. GetName plus, I don't know, if we say like name and score, how about that? We'll say name plus their name plus their score plus student.getScore. So this is when we read our files out, right? Okay, it's not too bad here, but now we can't just add that to name here. So what we need to do is once we have the line, if it's not empty, I'm going to take, so one of the cool things you can do with line is this option called split. And you can say, what do you want to split on? We want to split on a pipe. So if you give me a pipe character, I'm going to split that out here. I'm going to have a string for name is line.split, and this will give you an array of values here. So when I split it, let's actually call that values. How about this? I've got a string array called values. So when we split it here, and then we can add to the student. Here, this should be students. Let me refactor, rename this one. Students. We can add a new student, right? Given the values index of 0 should be the name, and then values index of 1 should be the score, but we need that as an integer, right? So integer.parseInt, given that values index of 1. So when we split it here, we should get 2 items in the array. First one being the name, the second one being the score, because we added that pipe character to put them together. All right, so that should work here, but none of these are going to be valid files now. So I'm going to go delete these files out. Let's go delete these. And go delete those ones. We don't need any of these because we need to recreate them with the new format. No, it's specifically an array list here in Python, or not Python, in Java. We're using the array list here. It could be the base array, right? It implements the list interface, but we haven't really gotten that far in this class. So we're just dealing with array list right now. We don't need any more of that polymorphism stuff. All right, let's see. Does it work? What was I trying to refactor here? I don't know what was going on with that. I don't know what I did. What's red here? Add another parenthesis there. Closing parenthesis. Cool. We added the new student. Is that all we needed? Let's try it. Let's see if we can make a file here then with scores. And this is why having all those out as methods was nice, right? We only had to update those methods. Test and Twitch. That's right. We're trying to delete those ones. Delete. Oh, no. Okay, so I don't want to delete them there. That's okay. What is it trying to do? Just delete the file. No, I don't want to say. Okay, that's because it was trying to do a safe delete. That's what it was doing. And it's saying, hey, you're referencing this code here. I got it. Okay, so let's create a file. Let's call this family again. So Eric and their score is 100, obviously. We'll have Joy with 90. We'll have Jeb with 80. We'll have Vivi with 70. We'll have Journey 60. We'll have Jubilee with 50. We'll have Jackson with 40. And then done, and the score doesn't matter. All right, so now we should have the family file with names and scores. Right, name, pipe, score. Just a fun little delimiter there. Okay, let's try it again, and let's see if we can read that file then. We read a file from family. Oh goodness, we broke. We broke. Number format exception for input string R. What about the solid substitution principle? Yeah, this is the first programming class, so it's a little bit beyond the scope of what we want to do. So, file trying to read an R. Why was it trying to read an R? I think I did something wrong with our parsing here. So let's see. So we are going to read the file, then I'm going to say, okay, if it's not empty, we'll split on the pipe, and then we'll go get that first one. So it must be the problem here. It must be failing on split. So let's run it in debug mode and try it again. So let's read a file, let's read family. All right, so we're about to split. So we have the line. The line is Eric pipe 100. Now we have a values collection here now. Uh-oh. That didn't split. Oh, goodness. Oh, okay. All right. So my split here is wrong. That needs to be the character, right? Character? Is that what it is? Why is it doing this? Not split. That does want a string here. Why didn't it take the pipe character? All right, something's not working right with the split. Let's see. Java string split. Okay. See what we get here. Look at that. There's a hit. Split on escaped. Oh my goodness. Escaped pipe. Huh. You know, I should notice it turned orange because that's a special character. That's interesting. Let's try it now. Maybe now it'll split. Let's see if it'll split. And we're going to cite our source because we're good people. We got this from here. That's a terrible URL. Oh my goodness. Gross. Let's see if it runs. All right, so let's read it, the family file. There we go, and we get their name and score. All right, cool. So we got that back out. So now updating, let's see if we can update a file here. So we made a file, we read a file, let's see if we can update the file. Come on, come on. There we go. So let's update the family file. This is who's currently in it, right? And we want to add more. Yes, let's add some more. Enter the student name. Let's add baby 7. And their score, obviously 0 because they're a baby. They scored none. Done, and the score doesn't matter. Now let's see if their family file got updated. Look at that, baby 7. Awesome. So we're able to update files, we're able to read files, we're able to write files that store information from our class here of the student class. Right? Again, this was just a little helper. We didn't necessarily need this sort of thing, but it makes life a little easier here. Kind of using that method. And we never used the set, but that's okay. We're not too concerned. Right, questions, thoughts, concerns? How you folks feeling so far? Let me see if we have anything from our... Excuse me. Right. If you want to append, so we're actually rewriting the entire file. We're not really updating the file. There is an append mode you can use. So when you go to open a file here, the file writer has an option for append mode. So you can give it an optional value here for append mode. So this is the append true. Say, hey, let's add to the file at the end, not erase everything from the scratch. So you can do that with file writer. It has this optional append mode, which is kind of cool. We'll say optional append mode. I don't know if that's helpful to leave it as like a, you put in a true here, but here, let's do that separate. We'll say this one here is the optional append mode. Is comma true. Does that make sense? Right, so this version versus this version. So you give it the comma true if you want append mode. It's a pretty handy one. Okay. All right, awesome. So we covered maybe half or so of the chapter. Again, we don't get into any of the binary stuff here. Just opening files, reading, writing files. That's sort of the basics that we're working at here. Because one of the goals, right, that we actually look at here is we can, where to go here? Write code that reads from and writes to disk files. So this is what Project 3 is all about, right? We'll write, I'm sorry, Project 4. Reading files, writing files, that sort of thing here. Okay? How you folks feeling? So I've been going for about another hour here. We got a little bit more to talk about. I think we're probably okay with exceptions if this feels okay. I don't want to get too much into the exception chapter, actually, I'm thinking now. It's like a little bit we could do with it, but not, I think it's okay. As long as this try-catch stuff makes sense, I think we'll be fine. And you can deal with the exceptions next class. You okay so far? Give that a little format. I think that's fine. Oh, what did it say? Reformatting. Remove custom line breaks. Yes. Right? I don't know. Sure. I don't know what that was. It's okay. So let's see, we have all of our files. So we don't actually need that first files project because that didn't work for us here. Let's get rid of that first one. I don't know what it was doing, why that wasn't running. Super confused. But the Maven project worked for us, so that's the good news, right? So here's files. Give that a commit and a push. And then when we take 10 minutes, and then we'll come back and we'll talk about the project 4, okay? That sound like a good plan? All right, cool. I'll put some music back on. Oh, did I close my music player? I did. Open the music player back up. We'll take 10 more minutes or so. Go get some more fluids, and then talk about the project. So I don't want to run too late without a break here. All right, folks, see you in a little bit. Howdy folks, welcome on back. Alrighty, so we've got to talk about the last project here. Let me pull up a link here for you. Take a look at this one. This will be for project 4. We'll do our Java template. All right. And those feedback pull requests. All right, awesome. Here's project 4. This will be, and hopefully you can get it done by next week. But if not, we've got till the 5th. It's okay. We'll be all right there. So let's see. This will probably be about 20 points or so. Again, trying to make it a little smaller here. We don't get to forget anything though, so we're still going to take advantage of classes. We're going to read and we're going to write stuff to files to try and manage these sorts of things here. So we should be in pretty decent shape here. So we want to also please submit a feedback pull request URL and a self-assessment using the rubric here. Okay, so we're going to set this up as projects for a text submission. There we go. This is files. Do you want a lab due next week for like some practice on files, or do you think this is fine and we're just kind of hoping we'll get it done in a week anyway because it's a little smaller? I feel like maybe not doubling up then would make this a little easier for you, if that's all right. So if we skip the lab and just go right to the project, or if you'd like the lab for practice, I'm happy to do that too. Just let me know. Okay. All right. No strong opinions one way or the other. That's fine. So let me make sure. Did I have all of our stuff committed? Good, I did. Close that one down. Okay. So we're going to write a program that allows a user to. We're going to sell tickets to shows. So it's going to be in 2 parts. So part 1 will allow them to manage the shows they are selling tickets for. Okay, so that this is essentially, we'll create a file with the show name and some number, any whatever number of tickets they want and whatever tickets they want to sell for that show. That should then create the file. The file then will be created with a list essentially of tickets and the purchaser's name and a random verification code. Okay, so we're going to have 3 things. We're going to have a ticket number, receipt number, right? So we're going to use a ticket class. So use a ticket class with attributes for ticket number, which is like 1 through whatever. So like if they want 50 seats, we'll have ticket numbers 1 through 50. If they want 1,000 seats, ticket numbers 1 through 1,000. We'll have the purchaser's name or empty if not purchased, and a random verification code or 0 if not purchased. Okay, so the ticket class then will have the ticket number, the purchaser's name, and the random code, either 0 or empty being like a empty string like that, if it's not been purchased. So we'll write that to the file then when we are managing the shows that we're selling. Right, and then so that's the manage mode, and then we can also okay, that's part 1, or maybe like option 1, right? Option 1 allow them to manage the shows they're selling tickets for, and then option 2, just go down, there we go, option 2, allow to sell tickets for a show that they specify, right? So, hey, give me the show name. So this should then go and read the file for the show specified, loading the tickets into an array list. And then we want to ask the user to enter their name, or their ticket number, their desired ticket number and name. And if the ticket isn't sold, right, so it has blank name or 0 code, add their name and generate a random number. We'll say, let's do like between 100,000 and 999,000. So like a random 6-digit number will be their code here. Okay. If it, and then allow to pick a different seat. A different seat if the one they wanted was already sold. So like, hey, what seat do you want to sit in? And they say seat number 5. We'll go see, hey, is seat number 5 already taken or not in that list of tickets, right? So we have to go load those tickets into the array list and go find the one that's seat number whatever, see if it has a name or not here. And then option 3 will allow them to print a report for a given show, which prints all the tickets, seat number, info, purchaser's name, and random code, random confirmation code. Okay, so kind of similar to what we're doing with these student lists, right? You can open them, you can read them, you can update them. So the updates here, though, are a little different, right? We're not adding new values. We're going to say, okay, hey, do you want to buy a ticket for this one here? Okay, so then we're going to have our rubric here. For this is 20 points. Should be pretty quick. We'll just do like 4 different sections, I think. Excuse me. So it's either missing or it's complete. So you get 5 points just for the ticket class here. Has required attributes and required private attributes and public methods. Right, so public gets and sets private attributes here. And then we're going to have manage show option to create new files, the sell ticket option to update files, and then the whatever display show report displays all tickets, names, and codes for a show. Okay, so that should be 20 points there total. So worth like 1 point less than Project 3. We don't need to go through all the unit testing for this ticket class. There's not a lot of logic in here. We're just going to go through these 3 options here, and then allow them to continue picking an option until they're done. Right, so hey, do you want option 1, 2, or 3? And then put them back. Do you want 1, 2, or 3, or do you want to quit? Where like our little file example just quit at the end was kind of annoying. We had to restart it if we wanted to go and read any of the files and stuff. Okay, so that's what we're going to work on. So we got 2 weeks. Hopefully we can get this one done in the week. Don't forget we have study group tomorrow, 12 to 1. And then next week, before class, 5 to 6. We're going to keep on that pattern here. And I think, did I forget to post the quiz for arrays? I think I did forget to post the quiz for arrays. I'm sorry about that. I will post that. Yep, I totally forgot to do that. I'll post that quiz. We'll make that one due next week because we don't have a quiz on files. We didn't cover the whole chapter. I don't want to like go through and kind of pull out some of the miscellaneous ones there. So we'll work through this chapter 11 quiz. Sorry about that. This week, okay? Oh, this restrictions is what I want. here, so we'll make it active for you folks. So let's make that next week, 11:59 p.m., okay? We don't need to hide it. All right, if you got any questions, thoughts, or concerns, let me know. If not, I will see you folks next week then. All right, you take care, everybody. Oh, we should go read out somebody. That's right. Say hi to some friends in Twitch land. Go say hi to our friend Hermit again. He's always good for a pick-me-up. We'll head over that way. Say hi, and we'll go over there. Folks, take care, and see you around.